we want to talk about functions. So suppose we have two collections of objects. There are some elements in the object. For each object on the left collection, there is only one correspondent object on the right side. So for each one on the left side, there is only one correspondence to the on the right side. One in the left side, only one on the right side. Okay. And the connection between the elements from the left side and to the right side is called function. So the elements on the left side is called the domain of the function, and the elements on the right side is called the range of this function. Sometimes we call the domain as the input. We have some input here, then through the function you will have an output. The range is called output. So you can see from this is the definition of the functions. You can see the definition of the function. Very important thing is the elements on the left side corresponds to only one on the right side. So if you have a relation, right? This is some elements on the left side. This is some elements on the right side. If you have some relation like this one corresponds to this one corresponds to it, and this one corresponds to it. Okay, let's look at this one, this example. This is not a function because for this element on the left side, there are two correspondents on the right side. So it's not a function. Okay, the function must be the elements on the left side in the domain. There corresponds to only one element in the range. Okay. So now let's look at some examples. Let's look at this is some relations. The collection of the points, -7, 2, and this is -3, 1, 8, and 2, 3. So you can see this set of the points tells you that 7 corresponds to 2. -3 for this point, -3 corresponds to -3. 1 corresponds to 8, and 2 corresponds to 3. So you can see this is the left side and this is the right side. So this is a function. This is a function. This relation is a function because one element on the left side corresponds to only one element on the right side. Let's look at another example. -7, 8 is 1 point. -7, 5, 2, 2, 4, -8, 10, 6. Okay, so now let's look at the corresponding. -7 corresponds to -8. -7 also corresponds to 5. 2 corresponds to 2. 4 corresponds to -8. 10 corresponds to 6. So from this chart, you can see that this -7 on the left side corresponds to two elements, -5, -8 and 5 on the right side. So this one is not a function. Okay. Another example. If you have a set, this is the Bob, Ann, and Dave. Okay. There's another set, which is the foods they like. Bob like carrots. Ann like peas. Vegetables, actually. Dave like peas and squash. Likes peas and squash. So this is not a function. The reason is there is one element, Dave, corresponds to two elements on the right side, peas and squash. Okay, so this is not a function. So sometimes we can use a function, we can use this one. We use y equals f of x to represent a function. Okay, where the collections of all x is called the domain. The collection of x values are called the domain. For each x, there is one y values corresponds to it. Then the collection of the y values is called a range. So sometimes x is called input. This is called input. And this would be the corresponding output. Okay. So now let's look at if you have one input corresponds only to only one output, then this is called a function. Okay, one input, okay, or one x corresponds to only one output or y values, then we say this one is a function. Okay, so now let's look at this example. So if you can write y as a function of x, then if you can write y in terms of x, then it's a function, right? So let's look at this one. 2x plus 3y equals 15. Okay, so now let's try to find this form. Okay, we want to determine if this one represents a function. So we solve for y. Y equals what? 3y with minus 2x, right? 15 minus 2x, then divided by 3. So this is the 15 minus 2x divided by 3, right? This is actually a function. So y is a function. Y is a function of x. Why? Because for every input x, there is only one output y. Only one. Right? You cannot plug in x values, then you give more than one output. There's no way for this representation. Right? So this is the y is the function of x. So here f of x, y equals f of x. What is f of x? F of x is given by this one, 15 of minus 2x divided by 3. Right? Here f is called the name of the function. So the input is x. How do we get the output? We use this way to get output. We multiply by 2, then 15 minus that number divided by 3. You get the output. So this is the function. So if you can write the equation in terms of y equals some functions of some expressions of x, then you can see the function y is a function of x. But this one is not. For example, x squared plus y squared equals 1. If this one is a function or not. So let's try to solve for y. Y squared equals 1 minus x squared, right? So y equals plus or minus square root 1 minus x squared. Right? We take the square root, right? You have plus minus here, right? You square it, the minus would disappear, right? So you will still get y squared equals 1 minus x. So in other words, for this one, this is not a function. The reason is for each element input x, then there is 2 outputs corresponds to 1. One is the positive one, the other one is the negative one, right? So this is not a function. The reason is here, plus or minus sign here. So if we know the graph, how can we identify a function, a curve represent a function? So here we called which is called the vertical line test. What does this mean? So if you have a curve, you draw a vertical line anywhere you want. So you can see there is only one intersection point for each vertical line. Then this one is called a function. Why? Because the vertical line represents some x values. If there is only one intersection, that means corresponds to only one y values, right? But if you have the curve like this one, which is a circle, so actually this equation represents a circle. Okay, represent a circle. Why is this? We know from here, the discussion here, it's not a function. Why? We can use the vertical line test. Vertical line test. Okay, we draw a vertical line. For each x values, there corresponds to 2 intersections points. In other words, it corresponds to 2 y values, right? So this is not a function. So now let's look at some examples. If this one represents a function or not, we use the vertical line. We use a vertical line. So you can see there are two intersections. So this is not a function. Not a function. What about this curve? This is a function because when you draw a vertical line anywhere, you can see there is only one intersection point. So this is a function.